Good morning to all of you. Now we will discuss the previous class summary. Last class we discussed about the mechatronics design process. In that first, identification of the problem or need. After that, what are the specifications, what are the constraints, and what are the considerations, what are the requirements required for that particular identified problem to overcome for that particular identified problem. And then after that, we have to apply the methodology to overcome that problem identified. And after that, we can get the solutions. There are so many solutions by applying different methodologies. In that we can choose the best solution. That best solution, again, we have to go for prototype, to prepare a prototype. After that, we have to go for next stage is testing and evaluating. The testing and evaluating, you can get the results good. Then after that, we can release the product in the market. If not, if the results is not the desired values, then again we have to go for changes in the requirements or in the whatever the considerations we have to change. And then similarly, we have to go for another methodology to get the best solution. Like that, till that you can get the after testing, you can get the desired values. That is the mechatronics design process. And then next, we discussed about a system, measurement system, control system. Measurement system, I told you that it is a system or a device used to measure a physical variable. Right? Example, we discussed temperature measurement system, pressure measurement system, level measurement system. And also I said that system, what is a system? System is nothing but it comprises or it consists of a number of components assembled together and it performs some specific function which is useful. That is called a system. And control system, that means control system is nothing but it is also a one type of system which is used to control that particular system. For example, TV is controlled with the help of the remote. Likewise, last class we discussed about AC. Like the AC is controlled with the help of the remote. We can set the temperature according to our requirement. Likewise, and then heating control, like this control system. Now today's class we will discuss about the classification of control system. Classification of control system, microprocessor based controllers, advantages and disadvantages. Advantages and disadvantages of mechatronics system. The classification of the control system: open loop control system, closed loop control system, or feedback control system. This open loop control system we can also call it as a non-feedback control system. Non-feedback. Next, in the open loop control system, see here, this is in this plant is there, plant or system, and here the input is a variable, the controller. Here from the controller activating signal. This activating signal activates the system or plant, and then we can get the output. So here in this, if you see in this open loop system, the output here the output can be varied by varying the input. That means here the output can be varied. That means the output changes by changing the input. For example, take the fan. If the fan is operating without a regulator, example. So when you switch on, automatically what happens? The fan rotates. If the input is nothing but here electrical supply, in the electrical supply there is a changes in the current, the fluctuations, then automatically the fan speed will may increase or may decrease, or sometimes it may get damaged. That means here the input is proportional to the output. The output varies according to the input changes. The output varies according to the input changes. So that means here the output may sometimes changes due to some external disturbances. The output may changes. It means, for example, in some areas the temperature is too high. See here, if you observe our wall clocks, in summer season, it decrease the time, small, maybe 5 minutes or so. Why? Because here the needle, the pointer, due to the hot in the temperature in the summer season, automatically the needle will elongate. Thereby, the time will rotate so slowly. That means it's maybe 5 minutes or so. But in the winter season, the needle will rotate faster because it comes in the pointer will comes in contract position. So it rotates somewhat fast, 5 minutes. So there will be a change. That means the output is affected with some external disturbances. So that output here in this case, the output external, the output will change due to some external disturbance. That means maybe some environment. So that output changes will not be possible with the input variation. So that is the thing. Here, the output changes due to disturbance. It is not followed by changes in input to correct the output. It means we cannot able to change the output by changing the input. So this is the drawback here. That means here in this major advantages of this open loop control system is here it is very easier to construct, and also it is very simpler, and also it is not complicated. It is not complicated. The example I will tell you. We will discuss with some example. For example, here if you one tank is there on the top of the floor, house of the. That means here when you tank, we have to fill the water. When you switch on the motor, automatically here the motor is nothing but here it is a plant or a system. Plant or a system. When you switch on the motor runs, thereby the energy developed. It sucks the water from under the ground and then it is fed to the tank through the pipelines. And then whenever the tank fills, what we have to do? We have to switch on. That means here the manually you have to perform on the system. We have to give the input manually. We can get the output. Are you understand? Here the motor is there. When you switch on the motor, so the motor runs, thereby the energy develops. That energy is useful to suck the water from under the ground, and then it is fed to the tank through the pipelines. Till total the tank is filled with water, then again we have to go for switch off the motor switch. How to switch off the motor. So like this, so this is an open system. This is an open system. But if you see in the closed loop control system, the closed loop control system, here plant same or a system, controller, that means it controls the plant. Here the output is the physical variable. Here in this case, input is the variable. We have to the physical variable. We have to send. We have to set it, and the controller here it gives the output activating signal that activates the plant, and then we can get the output. This output value is not the desired value. That means the desired value means whatever you set the input value, it is not the output value. For example, if it is not the particular output value, then the signal sends to the feedback element. Here the feedback element, it filters the error. It filters the error, the feedback. That means from the output, the physical quantity which is not a desired value, it will send to the signal to the feedback element. Here the feedback element sends the signal to the error detector. Here in the error detector, it identifies the error. That is the difference between the output and the input. The difference between the output and the input. And then this error detector detects the error. That error signal sends to the controller. And then thereby the actuate signal will follow. This actuating signal will activates the plant in such a manner to get the output correct out. To get the correct. That is it. This is automatically. This closed loop control system is completely automatic. Closed loop control system is completely automatic. I will tell you that. Example, we will discuss. Example, we will discuss. Here, for example, in the input, for example, take the air conditioner. If you set the value 18 degrees centigrade or 19 degrees centigrade, if the output is 22 degrees centigrade, that means whatever you set the value in the input, that is 22 degrees centigrade, that is 18 degrees centigrade, the output is 22 degrees centigrade, the output. Here the output is 22 degrees centigrade. So then this output is not your desired output. Here in the input what you set 18 degrees centigrade, but the output what you are getting 22 degrees centigrade. Then here that output variable, that is the temperature, sends to the feedback element. Here the feedback element sends the signal to the error detector. Here in the error detector is the difference between the output and input. How much difference? 18 to, and here we are getting 22. 22 minus 18, 4. 4 degrees centigrade is the error. 4 degrees centigrade is the error. That error signal sends to the controller, and the output from the, this is the actuator signal, that activates the plant in a correct way, and then we can get the output till 18 degrees centigrade. That means whatever the input variable you have to set, the output variable will also be the same. Till that this process will continue. That means automatically it controls. That means here the output will not affect on the input. Here in the previous case, output will affect on the input. That means here it is independent. The output is independent on input, but here the output is in the closed loop control is dependent on input. So like that. In the open loop control system, we discussed about tank filling with water. Same example we'll discuss. Same example. In this case, closed loop control system. If you see in apartments, big apartments, around 300, 400 families are living. There, whatever bigger tank is there. See here, 300 families are living means sometimes the water level decreases fastly. Like that, here the security person, he has to switch on and off so many times for one particular day. So to overcome this problem, we have to arrange in such a way that automatically the motor will switch on and switch off without any involvement of the human. That is called in this, the advantages of this is closed loop control system. So without any human involvement, we can reach our output. See here, for example, in the tank, if you mark some particular level in the tank, bottom level, if that level reaches the water, automatically the motor will switch on. Motor automatically switch on. And at the top level of the tank, we have to indicate some level with the help of some sensors. Automatically, when it reaches the level of the water at that particular height, automatically the motor switches in off condition. So like that, we can set here automatically water level control. So without any human involvement. So this closed loop system, in other words, we can also call it as automatic control system. I will tell now the major difference between the open loop and control system. Here the output variable in the open system is not affected on the input. That means independent. That means that the change in the output will not be, you cannot able to change the input. That means we cannot change the value of the output. Right? Again, I'm repeating, all of you listen carefully. Here in the open loop system, the output changes. So that output changes will not followed by the changes in the input. Whereas in the case of the closed loop control system, the output changes by changing the input. This followed, the output changes, it will be followed to the input changes. And open loop control system, there is no feedback element. In the closed loop control system, there is a feedback element. And the next, this open loop control system is simply to construct. This closed loop control system is complicated. That means somewhat difficult to construct. And then here in this closed loop control system, in this some other engineering disciplines also, the engineers will be added. And then the main advantage in the open loop is, of course, it is main advantage is easier to construct. Whereas in the case of this closed loop, it is automatically output. So open loop and closed loop. In this, there are so many examples out there. We will discuss in the next coming. Same, another microprocessor based controller is there in the topic. We will discuss there. Some more examples of closed loop control systems or automatic control systems. Any questions? Anybody? Any questions? Any questions? So you can post in the chat box. Anybody? No questions? No questions? Anyone can, how the actuating signal gives feedback? No, here actuating signal, it will not use feedback. So remember this point. Here the actuating signal actuates the plant or system. Here the feedback, whatever the output variable, is sensed by the sensor and it sends to the feedback element. Actually, here in between, here we have to arrange a sensor. So here one sensor we have to arrange. That sensor will detect the output variable. Then it sends to the feedback element. Here the feedback element is completely nothing but feedback element, or in other words, we can also call it as a sensor. Are you getting the actuating signal? Sai Ganesh. Here the what is the function of the actuators means? It activates the system. What is the function? Activates the system. Maybe actuators are pneumatic actuation system, hydraulic actuation system, relays, solenoids, converters, that is analog to digital converter, digital to analog converter. These are the actuators. The function of the actuator is nothing but actuator. It activates the system. For example, I will tell you. Here a door, right? A door is opening and closing. Here, when you here the back side of the door top, we have to add one single acting cylinder. When you open the door, automatically the door will closes due to the actuations. That means here a single acting cylinder is there, back side. It pushes the door. Here it pushes the system. It pushes the, here what is the system? Here the system is the door. System is the door. Back side what you arrange is a single acting cylinder, that is actuator. That is actuator. It activates the system. That is, it closes the door. Close the door. When you open the door, automatically backside a single acting cylinder is arranged at the top, and then it pushes. That means a single acting cylinder is the activator to push the plant. That is to push the system. Here the system, what is the system? Door. Mr. 380 Raj, are you understand? Raj, you asked the question. Right. And similarly, if going on discussing, there are so many examples are there. Then next we will go for next topic. Next topic will go for next topic. And then here in this automatic control system, there are so many automatic control systems are there. Speed control system, level control system, what we discussed now. The tank filling with water, that is the level controller, right? Level control, that is here the height in the tank is vary. Height in the tank, that is the output. This output will set the input, it changes the input. Phone number 336. 336. Please unmute. 336. 336. What is your name? Three 36. Okay, chala raha. Please unmute. Correct. So here today discuss what I discussed. Speak out. Chala raha. Chala raha. Already you are unmute. Chala raha. Speak out. I am not getting your voice. I'm asking about the 336, a regular 336, not the lateral entry. Regular 336. So, Challara, you are the Pranit.
Hello.
Unmute yourself, Pranit.
Sir, Jason, sir.
Speak out.
Hello.
Open loop, right? Right. Right. Pranit, okay. The attendance is very low. And then one person asked, what are the examples of a closed system? That means any automatic. That means here automatically we can get our correct output. For example, see, in this closed loop control system, the major advantage in the closed loop control system, the output is accurate. Whereas in the open loop control system, the output is not accurate. That means the output is not our desired output. That is not the required output. Whereas in the closed loop control system, the output is accurate and it is desired value, required value. So now, in this here, examples, closed loop control system, so many examples. That is dishwasher, right? Automatic telling machine ATM, robot, and automatic spray painting. So, closed loop control system means it is nothing but automatic system. Automatic system. Without any human involvement, we can get the output. So now, number 344. So you got examples of closed loop system. Speed control system. These are all even I told you that the watches, the Titan watch, right, which is working mechanical gear system. That is also automatically the time will, that means the needle will rotate and then we can get it. Automatically we can get out. Remote system. With the help of the remote, we can control the system. We can get our. We can also do for fine tuning. Like this. These are all automatic systems. But now, next we have to come to microprocessor basic controls. Here in this C, 344, here I've written so many examples. Here a domestic washing machine. Like domestic washing machine, dishwashers, micro ovens, cameras, watches, video recorders, and if you come to our mechanical industries, computer numerical control machines. So these are all automatic control. These are all automatic control systems. That is a closed loop. What I said. 44. 44. These are all the examples of closed loop control systems. So many examples in the industries. Any variable you have to set in a desired value, then you have to go for automatic system. You have to go for implementing automatic system. So now we will discuss about this one. So only the percentage are 78. The time is 10:30. 80 members present. This is not good. Around 113 members are there. Only 80 members are. The last class around 90 members are present. Better improve your things. Come regularly online classes. Now here in this microprocessor based controller, here in this process is there or plant process or plant. Here the variable controlled variable, that means the physical variable should be controlled. Here it's sensors. I showed you the sensor, right? Sensor or a feedback. Sensor or a feedback. Here the variable here is sensed by a sensor, and that is nothing but a feedback element. Here it sends to the data acquisition. DAS means a data acquisition system. Here that means here the signal received from the sensor. Here DAS received the signal from the sensor and it gives the output. That should be read in the microprocessor. Read in and processed by the microprocessor. The value. That value you can read in the, I think all of you know that about the microprocessor system, right? Already you did some of the experiment in basic electronics, basic electrical and electronics lab. With the DAS is DAS, it converts one form to the other form. Here the sensor is the physical from the sensor, output is the variable, that is the input to the DAS, data acquisition system. This DAS converts that signal into the another form. It means here this is the analog signal. The output of the sensor is analog signal. Remember this point. This DAS will convert that analog signal into digital signal. That digital signal will read and processed by the reading and processed by the microprocessor. Here keyboard and display is there. This allows the user to set the desired value. And then that desired value sends to the actuator. Here the actuator activates the process variable and we can get the variable correctly. That is the process. Here main thing. Here this is also a closed loop control system. This microprocessor based controller is also a closed loop control system. But here the other elements are added. Here, for example, the previous sensor is there, or feedback element, and then here error detector is there. That here we are arranging error detector. Right? Right, like this. This is the closed loop previous. Here in the previous, this is the closed loop. Right? Here error detector is there. Error detector. It activates the things controller, process or a system or a plant, and we can get the variable. But here in this microprocessor based controller, the other element here participating in a major role, that is a DAS, data acquisition system. Here the output signal from the sensor is analog signal. That analog signal is the output to the DAS. The DAS, that analog signal converts into the digital signal. The output of the DAS is the digital signal that should be read in the microprocessor, that is microprocessor. And then here the keyboard and display, these two are there. This will help the user to allow or to set the desired value correctly. Then the actuator activates that particular variable in the process, and then we can get the physical quantity, correct physical quantity is a correct variable, that is a desired output. In this, there are so many applications are there. Domestic washing machine. That means that this completely embedded with some software inside. That is electronic control unit section is there, and some microprocessor, basic processor. Processor is there. That is the base micro. That is in other words, the microprocessor controller. It is microprocessor based control. And then dishwasher, micro ovens. Then the micro ovens also there. When you place the food inside the food court, then we have to set our output value temperature. You understand? Here we have to set the output as the input variable. When you set automatically, it will cook up to that particular point, and automatically it will shut off. And then we can take the food. So based on the voice is not clear. So now, at 334, my voice is clear now. Voice number 334. 334. Voice is clear. 334. Some other song. I am not getting. Sai Kumar. Okay, now it is clear. 334.
చెప్పములు పసుపుములు ఆర్కేగే
Three not 9. Please off your mic. Okay, now it is clear. 310. 310. 334. Okay. Yes, yes. Okay. Right. In this, the examples, domestic washing machines, dishwashers, micro ovens. The micro ovens, that means if you set the temperature correctly, it will cook up to that mark. That means whatever the setted input variable, that is nothing but our desired output. See here in automatic, that means washing machines, we have to set the whether slow rings or medium rings or fast rings. In ATM also, you have to give the input. You need 1,000 rupees. So the ATM machine will give only up to 1,000. That means whatever if you give the input, the output will be the same without any change. That is very accurate level. And one person asked that examples. There are so many examples are there in the closed loop control system. So many. For example, take in our household one of the appliances. That is iron box. Iron box. Iron the clothes. Iron box. That means all of you know that means iron box is automatically switch on and off. If the temperature reaches to that particular value, then automatically iron box is in off condition. When the temperature will reduces, automatically again the iron box will start on. Like that, in iron boxes, automatic switch on and off. Any closed loop control system, any automatically on and off device. And 334. Modern washing machines, the time is set according to the weight of the piece, right? That is depending on the weight variable. And also, if the weight is more, means automatically the washing machine may get damaged. Of course, the time is set. The time is also one of the input parameter. That is depending on the weight of the piece. The next, any other? And then if you go for manufacturing, that is computer numerical control machines. See here, in these computer numerical control machines, nowadays, see here in the third year already you studied, you performed so many sequences of operations on lathe machine, that means on the job. Maybe facing, turning, knurling, threading, like that. So all these operations, here if you perform work on the lathe, you are doing so jobs, maybe taper, turning, like that. That means otherwise consider a bolt and nut. So you prepared a bolt and nut with given dimensions. And then if you go for testing, maybe some tolerances will be more. Maybe sometimes it will fit, may not fit. That means error. If you go for CNC machines, if you write a program in part programming, automatically it will fed to the CNC machine, and then automatically the tool also will be changed. There are 6 tool posts or maybe 12 tool posts or like that. Automatically it performs operations on the job. So we can get our output correctly. Bolt and nut, for example, 100 bolts and 100 nuts. With the help of the CNC machine, you prepared, you manufactured. Then if you go for detect error, almost all out of 100, 99 will be correct. Maybe one will be small error wrong. Maybe the tolerance plus or minus. So while in the conventional lathe machine, that if you perform, that means you did that you manufactured that 100 bolts and 100 nuts. Out of 100, around 30 bolts and nuts will be under damage. That is the difference here between the automatic control system and open loop. This is the major difference. In this automatic control system, we can get the output with a good quality, and scrap is also very less. What I said, example. For example, 100 bolts and 100 nuts means to prepare through CNC machine by writing a part programming. Then almost all 99 bolts and nuts will be correct with the correct dimensions, accurate dimensions. No change in that. But while in the conventional, when the one will perform and prepare the job, perform experiments on the job, and then that out of 100 bolts and nuts, around 30 bolts and nuts will not reach the output, will not reach the dimensions, given dimensions. That is the thing. How you understand manufacturing, right? And robots, IC engines, windmills, etc. All these are being controlled by the microcontrollers. Any questions in this? Anybody? Any questions? Next, we'll go for the next one. The next, advantages of a mechatronic system. Here, see, less working hours. Here, example what I said, CNC. So within a less period of time, we can prepare through CNC 100 bolts and nuts. Whereas manually, it will take much more time. That means within a less duration, we can get more product. And then reduced lead time. The time will be reduced. Elimination of setup time. That means we can eliminate setup time. That means the time duration should be less and safer working condition. This automatic control, this should be safer work. Safe. It's very safe. That means there is no suffering in the working. That means safer working conditions. It means it's very safe. This automatic mechatronic systems and a better product quality. The quality should be very good, accurate. Greater extent for machine utilization. That means lifespan of the machine utilization will prolong. Wide area of application mechatronics in there is large areas, almost all in all areas applications, and possibility of controlling remotely. That means we can control. Chances is there with the help of even in the remote areas. And greater productivity in case of manufacturing organization. It means in what I said down, manufacturing, in industry's manufacturing side. So we can get a greater productivity with the help of these mechatronic systems. Then disadvantages of mechatronic systems. Lower skill levels of workers. See, that means in the mechatronic system, to operate the machine or a system, skilled person needed. That means lower skill is not preferred. That means a skilled or trained person only preferred. This means here in this high initial investment, the investment should be more in the mechatronic system. And unemployment, not suitable for short product life cycle. That means it is suitable for long product life cycle. Long productive cycle. Not economically justifiable for small scale production, only for larger scale only. Multidisciplinary engineering background. Complexity in identification and correction of problems. That means any problems, that means we have to identify, that means a trained person required to identify the, for example, the system is not working, then we have to identify the problem. That means that should be a complexity in identifying and correction of problems. Any questions? Are you getting my voice? Anybody can respond. Are you getting my voice? Are you getting my voice? Mr. 320, lateral entry. I am not getting 320. Lateral entry 320. You please unmute. 320. 320. It is audible. Lateral entry 320. Banu Prakash. Unmute yourself. Are you getting my voice? Okay, 320. You speak. Mute. Unmute yourself. Unmute.
Yes, sir. Audible, sir.
Audible?
Yes, sir.
Okay. So, okay. Then if there is any disturbance, please type message and post in chat box so that I can respond. correct. Any questions? Any questions? Any questions? No questions? Right, we'll take the attendance. Time is over.
Oh. Oh.
Sai Ganesh, you are making sound. Right. Okay, all of you respond in the chat box. Three not one. 301. Yes, okay. 4, 5, 7, 8, 9, 10, 11, 13, right, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 27,
ఏదో ఫోన్ తో
28,
కేబుల్ తో మొత్తం
29, 30, 31, 32, 33, 34, 35,
పోయిందా ఫోన్
35,
బ్లూటూత్ పోయింది బ్యాటరీ పోయింది
36, 37,
ఓకే
38, 39, 41, 42, 43, 44, 45, 46, 47, 48, 48,
కాల్ అయిపోయింది
49, 49, 50, right, 52, 52, 54, 55, okay, 56, 60, 61, 61, 63, 64, 65, 66, 67, 68, 69, 70, 70, 70, 70, 73, 74, 75, 76, 77, 78, 79, 80, 81, 83, 84, 85, 88, 89, 90, 91, 92, lateral entry 1, 2, 3, 4, 5, 4 options, 6, 7, 8, 9, 10, 11, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20, 21, 21, 23, right, 24, 25, 26, 26. 27, 28 present, 29, 27 present, 30, 31, 31, 32, 33, 34, 35, 36, 37, 37, 38, 39, 38, 40, 40, 40, 40, 40, 41, 42, 43, right, 43 present. And here the option is, today's option is 5, 7, 9, 30, 15, 35, 48, 49, 52, 56, 61, 67, 70, 73, 74, 76, 79, 81, lateral entry 9, 11, 12, 17, 17, 24, 17, 26, 26, 24 present, 26, 31, 38, 40, 41. Then today's class we will go for summary. Just today we discussed about the open loop control system, right? Closed loop control system and microprocessor based control system, and advantages, disadvantages of mechatronics systems. So open loop control system, what is the major difference between an open loop and control system and closed loop? Open loop system is a non-feedback element, whereas closed loop is a feedback element. Here in the open loop, the output is not accurate, whereas in the closed loop, the output is accurate. Right, the major is a closed loop control system. The construction is complexity, whereas in the open loop, it is easy. And microprocessor based controllers, these are I said so many examples, that is micro ovens, cameras, watches, recorders, computer numerical control in manufacturing. In industries, there is a wide range of microprocessor based controller and advantages and disadvantages of mechatronics system. Okay, thank you. Number 41, lateral entry present. Total today's option is 26 members absent today. So last class only 17 members are absent, but now again the absentee number increases. Okay, thank you all of you.